Hi, welcome to this video. In today's video, I'm going to look at a very interesting sum, the sum of 1 over n to the 6 as n goes from 1 to infinity. We previously evaluated the sum of 1 over n squared as n goes from 1 to infinity by using both ways, Fourier series and Taylor series. Okay, this is combining with the Euler series as well. And also we evaluated the 1 over n to the 4th as n goes from 1 to infinity equal to pi to the 4th over 90. Okay, but today I'm going to do the sum of 1 over n to the 6 as n goes from 1 to infinity. Okay, let's go ahead and solve this one now. So as you see, the general formula of the Fourier series is f of x equal to, so let's set, so this one, when we have this function f of x equal to x cubed, so this is implies a sub 0, okay, equal to 1 over pi f of x cubed dx. Okay, so if you take a look at here, this is the odd function, this should be 0, okay, because it's symmetric to the origin. We have a sub n equal to 1 over pi, a sub n equal to 1 over pi is multiplied by integral minus pi to the pi, f of x, which is x cubed, is multiplied by cosine nx dx. This one equal to 0 as well, because the function as a periodic function from this interval minus pi to the pi is an odd function which is equal to 0 because it's symmetry to the origin. Okay, so what's left? X cubed as a function equal to this one, the sum of b sub n is multiplied by sine of nx as n goes from 1 to plus infinity. Okay, so I will work on this one now. Okay, as you see here, the bn equal to 1 over pi from minus pi to the pi, a function x cubed is multiplied by sine nx dx. Okay, as you see here, this function is an even function. Okay, because we have x cubed is an odd function is multiplied by odd function. I'm not going to use the by part as an integral because it's a long way calculation. Okay, so I'm going to use a technique shortcut. So if you take a look at here, we have this function x cubed sine nx. Okay, I'm going to use a technique shortcut is taking us quickly to the answer. Okay, so this one, if you derivate this one, x cubed is giving you 3x squared. If you derivate 3x squared is giving you 6x. If you derivate 6x is giving you 6. If you derivate 6 is giving you 0. The first term we put the plus sign, the second term we put minus sign, the third term plus sign, the fourth term minus sign, the last term plus sign. Okay, for the sine x, so if you integrate sine nx is giving you minus 1 over n cosine nx, because if you derivate this one, it's taking you back to the original one, which is sine nx. If you integrate this one, is giving you 1 over minus 1 over n squared sine nx, because if you derivate this one, is taking you back to this one. The other one, it will be plus 1 over n cubed. Okay, cosine nx, because this is the integral of this one. So if you derivate this one, is taking you back to this one. Okay, the last one, the integral of this one is giving you this one, because if you integrate this one, if you derivate this one, it's taking you back to this one. Okay, so this one is plus sign as well. Now I'm going to multiply this one by this one, this one by this one, this one by this one, this one by this one. Okay, so I'm going to calculate b sub n. If you take a look at here, this is the even function. I can rewrite it on this form as well. Since this one is an even function, so that's mean b sub n equal 2 times over pi is multiplied by this integral from 0 to pi. X cubed is multiplied by sine nx dx. Okay, what I'm going to do now, I'm going to evaluate this one. B sub n equal 2 times over pi. Okay, this one is multiplied by this one, is giving us minus x cubed over n is multiplied by cosine nx. The second term of this one, minus sign with the minus sign, is giving us plus sign, plus 3x squared over n squared is multiplied by sine nx. Okay, the third term is giving us plus, the third term is giving us plus 6x over n cubed cosine nx. The last term minus 6 over n to the fourth sine nx. Okay, so the bound from 0 to pi. Okay, because from based on this one. Okay, so I'm going to evaluate this sum 2 over pi. If you take a look at here, this one, this sine, this one equal to 0 because we have sine. If you this one equal to 0 because if you apply pi into the sine, is giving you 0. This one is 0 as well because if you apply pi into the sine, x is giving you 0 as well. So what's left? 2 terms. Okay, I'm going to apply pi here, minus pi cubed over n cosine n pi. Okay, apply pi into this one, is giving us 6 pi, okay, over n cubed cosine n pi. Okay, minus 0 because if you plug 0 into x, is giving you 0. So this is b sub n. Okay, now let's clean up the board and move on to the next step. Okay, in the last board we were working on this one and we came up with these results. So I'm going to simplify this one a little bit. Okay. I will have minus 2 pi squared over n is multiplied by cosine n pi. I'm going to transfer cosine n pi to minus 1 to the n. Okay, this term will have 6 multiplied by, I will have 12 over n cubed is multiplied by minus 1 to the n. I'm just changing cosine n pi into minus 1 to the n. Okay, so what I'm going to do now, I'm going to apply the Parseval theorem. Parseval theorem, we have the sum of b sub n squared as n goes from 1 to plus infinity equal to this integral 1 over pi from minus pi to the pi x cubed squared dx. Okay, this is Parseval theorem. I don't do all the terms in the Parseval theorem because a sub 0 and a sub n are equal to 0. Okay, so I have ended with this one now. So I'm going to calculate this term. As you see here, this is the even function. As you see here, this integral 1 over pi minus pi to the pi x cubed square is giving us x to the 6 dx. As you see here, this is function. This one is even function, so we'll have 2 times over pi 0 to pi x to the 6 dx equal 2 pi. I'm going to look the primitive for this one, which is 1 over 7 x to the 7 from 0 to pi, which is 2 over 7 is multiplied by pi to the 6. Okay, I'm going to, for the Parseval theorem, we have b sub n equal to this term minus, I'm going to multiply by minus 1 to the n and number. Okay, so we'll have minus 1 to the n. Outside I will have minus 2 pi square over n plus this term 12 over n cubed. So as you see here, with this n is a natural number, it's n different than 0, okay? So I will have, this implies b sub n, because we're doing the absolute value for b sub n, okay? So the absolute value always, it comes with absolute value, okay? So in the last board I was working on the Parseval theorem and came up with these results, okay? So I'm going to calculate b sub n quaternary square. So for n is an integer with n is not equal to 0, okay? So we have absolute value of n quaternary square equal to this one, minus 1 to the n, okay? So this one is a positive, is this one minus 1 to the n, which is 1. I'm going to calculate this one inside, okay? So this one is a 4 pi to the 4th over n squared plus 2 times this one is giving us minus 24, minus 2 times 12 is 24, is multiplied by 2, which is minus 48, minus 48 pi squared over n to the 4th, okay? Plus 12 over n cubed quaternary square, which is 144 over n to the 6, okay? Since this one is a positive number, so now bn square, I'm going to simplify this one. I'm plugging this one into the Parseval theorem. To apply this one in Parseval theorem, so I have bn square as n goes from 1 to plus infinity equal to the 1 over pi integral from, it's 2 times because it's an even function, 0 to pi x to the 6 dx. We found 2 over 7 pi to the 6. So what I'm going to do now, I'm going to plug this one into this sum. As we have here, this is Parseval theorem, okay? We found this result, we found this value before, so I'm just plugging now. So the sum of 4 pi to the 4th over n squared minus 48 pi squared over n to the 4th plus 144 over n to the 6, okay? As n goes from 1 to plus infinity. So I'm going to split this sum into 3 parts. So I will have, for the first sum, I'm taking 4 pi to the 4th outside of this sum because it's cancelled as a constant. The sum of 1 over 2n square as n goes from 1 to plus infinity. The second sum, I will have 4 minus 48 pi square is multiplied by this sum, 1 over n to the 4th as n goes from 1 to plus infinity. The third sum, I will have 144 is multiplied by 1 over n to the 6 as n goes from 1 to plus infinity. The whole thing equal to 2 over 7 pi to the 6, okay? As we found before, is pi square over 6, pi square over 6, okay? Minus 48 pi square, okay? This sum is a pi to the 4th over 90, as we found before, pi to the 4th over 90. Third sum, that's what we need to calculate, so which is 144. The sum of 1 over n to the 6 as n goes from 1 to plus infinity equal to 2 over 7 pi to the 6, okay? I'm going to bring this one at the top and continue with our problem. So we already found this expression. So I have written these terms in different colors to show you these values were replaced by these sums, okay? It's 8 over 15 is giving us minus 8 over 15 pi to the 6, okay? Plus 144, we have 2 over 3 minus 8 over 15 to the pi to the 6, 2 over 15 multiplied by pi over 6 plus 144, the sum of 1 over n to the 6 as n goes from 1 to plus infinity, 2 over 7 pi to the 6. Okay, I'm going to bring the pi term to the other side, so I will have 1 over n to the 6 as n goes from 1 to plus infinity, okay, equal 2 over 7 minus 2 over 15, okay, pi to the 6. We found this one. We will evaluate this one. Is giving you pi to the 6 over 945, okay. So I have done with this problem. Don't forget to hit the subscribe button below. So thank you for watching. I will see you in next video. Bye.